Alright, welcome back to the channel. So for some time now I've been meaning to create a video tutorial around this project here. It is a basic Golang REST API with CRUD functionalities for products. It is essentially a continuation of this project here, Go REST API with Mux. The only difference is that I'm using products instead of books. That's what we have here, a basic Golang REST API. The only thing is that I added the database aspect to it. Brad is pretty much one of the most awesome YouTubers on this whole platform here. I'm pretty sure that once you're in web development or in any sort of development, you probably would have come across Traversy Media at some point. While learning Go, this was one of the tutorials I was really following, and he also always suggests that you like code along with it and even add to it. So that was what I was doing, coding along, and I wanted a database aspect. Well, he mentioned that he was going to add a database aspect to this, but I don't remember seeing that tutorial coming out. So I decided I wanted to add a database aspect to it, and I went ahead and do it because that's something that he always recommends, that you just add to it and not just code along or just follow along just so. And I'm really grateful for this guy. He's pretty much one of the most awesome YouTubers out there, honestly. So the package that we're going to be using is the Go PG package. It has this migration thing here for database migrations, but I haven't really looked at that before, so we're just gonna keep it simple. We're gonna be using the PG package for the ORM, and we're also going to be using the Gorilla Mux router, and this is just for the routing, as you would have seen also in Brad's video, which I highly suggest that you guys go ahead and watch first, even before um, going into this tutorial. The next thing is that we're going to be using environment variables for the database connectivity. So I strongly recommend that you guys always use environment variables. This is something that YouTubers don't necessarily always portray in the right way. They say that you should use it, but then they just type it out. So I want to go ahead and show you guys how to exactly do that. And for the UUI, for the IDs, actually, we're going to be using UUIDs. This particular one from Google. So this is a pretty awesome package that I've used before, and it's easy. So I'm just decided that I'm going to be using that. So let's go ahead and get started with this thing right now. All right. So the first thing that we're going to be doing is to actually create the project. So let's go ahead and cd into our projects YouTube, and I think I only have view folder in here, so we can go ahead and make a directory, and I'm going to make two directories. So we're going to create one for Golang, and then we're going to create one called Go Product REST API, and this is where our project will be stored basically. So that's created. We can now cd into Go Product REST API, and then we can do a Go mod init, and this will be hosted pretty much at github.com/edu/Fedora/Golang product REST API, and we did that go mod. So if we do an ls, we get that go mod directory. And to make this more simpler or better for you guys to see, I'm just gonna go ahead and open that in code. That open on my other screen, so let's go ahead and open it here. I'm going to expand that. It's a little bit small, so I'm going to increase the size of it. And there we go. So now we have our initial stuff. First thing we're going to create is a main folder, which we're not going to be touching just yet, but I just want to go ahead and make this main main folder here, and then just create our main function, and this doesn't return anything. And that is pretty much all that we're going to be adding in here for now, at least. All right, so next thing is that we want to ensure that we can get some amount of connectivity to the database. So we're going to go ahead and create our database .go file, and we're gonna keep everything in the package main. Just to keep this simple, we're going to just have everything inside of the package main. So the first thing I'm gonna do is create a connect function, and I'm actually gonna go ahead and use lowercase letter because we're in the same package, so we don't necessarily have to keep it public, because it should be exposed to the different functions and all that is within the same package. So let's create the function main, and this is screaming out because it's not yet used. So before we can even move forward, we need to actually import the whole library, which should be at, before I'm gonna need more imports, so let me just start from there. Do github.com/gopg is /pg, and then here I can just do a hover and add this to the project. And you can see that it's running go get here, still underlined because it said that it's not used. So this package here, it requires some options, so we're gonna create this variable here called ops, and this is going to be set equal to this here, which is our options, and we're gonna pass these in. So we're going to have a user, and I'm gonna put a string variable here for now. It's gonna take a password, gonna add string here for now as a placeholder, and address, same thing. The database name, same thing. And the reason why I'm doing this is because we haven't yet created the environment variables, and that's what we're going to be doing shortly after finishing up this function here, so we can add those in. Next thing is we're going to create a database pointer variable, actually, that the data type should be a pointer to db. This is going to be set to pg.connect. So this is our connection right here, our different connections actually. So let's go ahead and do that. We're just gonna add the options from here. That's what we're doing there. We're checking if the database is nil, which means that the connection was not successful. So we can pretty much just go ahead and log that out to say, well, this should be, let's just do a printf. We want to format something in here. So printf, and we're just gonna say the database connection failed. So we did not connect to the database basically, and create a new line here because we want to also exit with a code of 100. If that's not the case, basically meaning that if we get the connection successfully, then we can go ahead and log that as well. So we can say a printf, and we can say the connection are connected successfully, connect successfully, or connection success, connect successful, basically. That should be it. And you can see up here that we auto imported some stuff. So for example, OS auto imported, and we also auto imported log. That's on save with the IDE, which is pretty awesome. Or I think it's the FMT, the whole Go thing. Next thing that I want to do here is to actually do a return, because we're gonna need the connection, but I didn't really implement that at first. But we want to return the database here, which this type is actually just this right here. So we could pretty much just copy this, Control C, paste it right here, and now we're returning the database connection because we're going to be needing that, we're going to be using that. So that's pretty awesome. So that's that. We probably should actually test this out to see if it's connecting successfully. So before we can even move further, we want to do a create of the .env file. And anytime you create a .env file, I extremely strongly recommend that you just go ahead and just add a git ignore, especially if you're going to be adding this any public Git repository. So you add a .git ignore, and then you just add the env file so that it's not committed to your Git repository or anything like that, or you don't accidentally do that. The second thing that I recommend that you do is just to go ahead and create a .env.example file, and this is the one that you would typically commit to any sort of Git repository that for persons who will be actually using that. So what we're going to be adding first of all is the DB user. So these are the variables, the environment variables that we're going to be using. I said BD, that should be DB, and create the DB password. DB password, and we want the DB address. we want the DB database. And I like to use this type of uppercase syntax. Find it pretty useful, I guess. So just gonna copy these over because these are the examples or the NV that we're going to be using always, basically. So I'll just copy it over to the example file. But now we are now inside that env, the main one. So the user should be the Postgres user or the user that's currently logged into the machine. Doesn't really matter. I'm just gonna do this here. For the password, I don't think this is actually required, to be honest. But I do have a password that I found here or something. I think this might be it. So I'm just gonna paste that in. We also want to add localhost, and you don't want to leave the port off. So you want to add that to the port here. So that make sure that that's added. The next thing is an actual database name. So I haven't created this database as yet, but I'm just gonna add the name here. So it's Golang underscore product underscore REST API. So you can see we have the syntax that, as far as I know, Postgres uses. So that's the use underscore instead of the dashes. So let's go ahead now and actually create this database. So we are going to clear this out. So let's go ahead and go to the Postgres user, and then we can do a create database, and we give the database a name. So we can say Golang underscore product underscore REST API, which is the name of the database that we have over here in our environment variables. We could also just add that we want the owner to be the Postgres owner, and then we can add our semicolon. Please don't forget to add the semicolon to end the statement, and then click enter, and that will create our database there. So if we go ahead and do a change to the project, well, to the Golang, you can see that we're now connected to this database here, and have an update, but that's not important. So let's go ahead now and do the connection. So the next thing is pretty much just to add the environment variables inside of here. So back in our database file, we can pretty much just swap this out. So we can say os.get and the database, the environment variable name, which is our db.user, and because I'm lazy, I'm just gonna copy this thing here, paste it in, change here, same thing for the address, and the same thing for the database. All right, so there we go. So now we have everything that we need, and this is pretty much just keeping it simple. We could add more checks and validation for a database connection, but for this application, we're just gonna keep it as simple as possible. Now we're gonna test the database. So we're getting the connection from the DB. So what we're gonna do here is just to pretty much just say set that equal to it, and now we can what can this do now? We want to close this, that's for sure. So we want to do a defer, and every time we open the database, that's one of the most important things that we want to do, is to ensure that it's closed, and we want to do this as the last thing. So we're gonna just add defer. So if the database connection was successful, what will happen is that it will print out this message here that we were successfully connected to the database. If not, it will give us this failed message here. So we can go ahead and exit this here, and then we can go ahead and run the whole program. So one thing that you don't want to do in this instance is to go ahead and do something like go run main.go, because if we do this, we're going to get this error here to say that it's undefined, that connect is undefined, because it's not running this file here, which I thought it would initially, because we're basically just injecting it into the main. So it would have I would believe that it would automatically just pull it in, but it doesn't do that. So what you want to do is to do go run dot, which will run all of the files that has a Go extension on it. So that's what we're doing here. You can see that it says that the connection was successful. So that's pretty awesome, and that's what we want to be seeing. So right here, we don't need this anymore. So we can get rid of that. We're just gonna comment it out for now, and I'll just add a comment here and say this is the database connection. So next thing that we want to do now is to actually create our models, and we're gonna create a whole file for that. So let's say models.go, and this is where we're gonna add all our models. Again, this is going to be inside of the main package. I strongly recommend that you guys just go ahead and create like a separate directory for all of these. That would make a lot more sense, especially for a more production-based application. So let's go ahead now and create our struct. This will be our product struct. So this is the first one that we're going to be using. We're going to add actually two structs. So our product and where the product is coming from obviously has to be sold by either individual or a store. I'm going with the store, so that's what we're going to be adding as well. So we want to add the ID, which is going to be of type string, or actually we could do UUIDs, to be honest. Oh, here we go. So we have an option for Go uuid, so we can get that automatically imported, and we're gonna go ahead and do go get for this package. It's running the go get, so now we have it in here. So we're going to be using uuids. I think we have to say uuid, is it? I don't remember, but I think that's it. So uuids, and then we're gonna put the JSON format on here. So this is going to be ID. I'm gonna double check that this is oh, it has to be. So let's leave it as that. And then the next thing is the name, which is going to be of type string. Same thing that we're going to be adding here, JSON, this, and because I'm now lazy, I'm just gonna go ahead and copy this so that we can use it again. And this is going to be name, and the next thing is going to be quantity. This is going to be of type integer, and we can go ahead and now paste that. So you see that our laziness is going to be paying off there. The next thing is going to be our price, and I usually put price as int, but for this example we could actually just go ahead and put float 62, I guess, and paste again, and this is going to be our price, and store, and this is going to be a pointer to a store struct again. Paste that in. This is going to be our store here. That's pretty much all that we need. The reason why this is screaming out is because this is actually not declared. So we're going to go ahead and just declare that now. So this is going to be our store, and you can see that now it's gone. So one thing that I'm not necessarily doing that much in this tutorial is actually creating the actual relationship between these two entities. All we're doing is just storing an object of it. And the relationship is something that I think I would like to add. So if that's something that you guys think would be interested and you would like to see that, you guys can let me know if that's something that you want. So I'll add that in a later video. But for this one, we're just gonna go ahead and do a simple one. So when I use UUID, it's just the same. And again, I had that pasted, so it makes it much easier for us. And it will have a name as well. And I can type, it's wrong. All right, string, same thing, name. All right, there we go. And now I can save, and this is auto formatted, which is pretty awesome. So this is pretty much it for our models. So this is all the models that we're going to be using. And again, everything is in the package main. So the main package, so we can access these really easily. I think I could even put this as lowercase letter, and it should still work, because usually when it's lowercase it means that it's private to the package, if I remember correctly. But moving on, so even if we want, we could really test it out to create one of these structures. So we could pretty much go ahead now and do something like product. Let's do product, then ensure that everything is working. Why can I not type the thing correctly? Product is equal to a product struct, and this will take in an ID, and I'm just gonna go ahead and say uuid is dot new uuid dot new actually, and then this takes a name, and I'm gonna call it my product because I can't think of anything original right now. So, or probably that's the most original thing. Quantity, this is going to be like 10, let's say, and for the price, this is going to be like 49.99, and the next thing is a store, which is also a struct, which I'd have to also create, and I don't want to do that. So let's see if we can just leave that out, and then we can do something like fmt.print line and just print out the product. So let's print out the product, and we can now go ahead and run this, and there you can see we have our ID, we have my product as the name, and we get nil for the store because we didn't add that. We also have the quantity and the price. So let's go ahead and continue now. So this is just for example to show that that's working as it should. These are screaming at us because we're not using it, so we're gonna save, and that will just remove all of those. And at this point, I would like to go ahead now and just add the ability for the database schema to be created. So essentially, what we would want to have here is actually that migration package that I had showed you guys earlier. But because I haven't really looked at it that much, and this is what, and just creating a schema is what I would have used in the previous project that we're following along with. I'm just gonna go ahead and use a create schema function that they actually have on in the documentation, which is pretty simple. That's an easy way for us to go ahead and just create out the database schema from the structures that we would have created. So basically from these models, that's what we're going to be creating them from. So let's go ahead and do that now. So we're gonna go over to the database. So maybe later on we can look at how migration would work, and that would be more sophisticated, assuming that it would basically create the tables for us and also make the updates as per changes. So let's go ahead now, create the function. We're gonna call it create schema, and this will take the DB. So let's put the type .db, and this will return an error if there is any, and that should be the type. Yep. So here we can do basically create a variable at this point that's going to be a slice of interfaces, which is pretty much going to pass in the structures that we want to be created. So let's go ahead and do that. So interface, and now we're going to pass in them. So I think there should be pointer to, for first one is the product, and then we're gonna add nil. Why do I have two of these brackets here? I only need one, and there we go, pass nil. Next, we need a comma here. The next thing is for us to add the store, which is because we're gonna have two of the store as well, and nil again. I'm just going according to what the documentation is saying. That's what we have here. So the reason why we're creating this type of structure here is because we want to not necessarily have to go ahead and create the singularly or one of them each time, or create basically duplicating the code. That's something that we don't want to do. We always want to keep our code as dry as possible. So what we want to do now is to actually go for a for loop, and I'm actually going to do the range. So we're going to do model in the range of models, and in here this is where we're going to go ahead and do a create of the table. So I'm going to pass the model inside. So db.model, why am I not doing this correctly? Model, there we go, pass the model that we have here in the range, and then we're going to do a create table, and in here we need to pass some options. So we're going to pass ORM options, or table options, and we're just going to set temp to false, and I have no idea what this does. I just know that it is what's inside the documentation. I didn't do that good properly. So let's go ahead and do it again. So it needs to be inside of here. So it takes a couple of these, which is, now that I'm looking at it, it's pretty awesome. If not exists, I want to set that to uh, if not exists, I want to set that to actually false, and I don't see. Um, I want to set that to true because we're gonna leave this function always running. So if we need to create a new struct or a new struct in the database or a new table in the database, all we do is just come here, go ahead and paste it. For example, if we need to add users to this, then that's pretty much what we would do. So this is where this part would become very important, but I don't know exactly how the format goes. If it's going to be like if if not exists, then it what happens is usually if it's not existent, that's when we would create a table. But if it does exist, then we pretty much would just ignore it. I don't know what this step does, so I'm gonna remove that. I'm gonna leave, and I'm just going to leave the if not exist, and we're gonna set that to true because that's pretty much all that we need in here. So that's that, and this is why it's important for us to go ahead and actually read the documentation on these things because that's important. This actually returns an error, so we're going to have to get that as well. We want to check if we're getting any issues. So if we have an error, then we're going to return that error. So we get that. And the final thing is that we want to return nil if everything goes well. So that's pretty much all that we're going to be doing for the create schema function. So after we get the connection now, so we want to actually do this and just pass the DB. So this is pretty much just a perfect place to add it uh, just after we get the successful connection. But one thing we need to remember is that this thing actually returns an error. So we want to go ahead and capture that right here. And we want to check if there's an error. What I want to do is to actually log this out. I think I could do log.fatal because I want to stop it. I think this should stop it. I don't remember exactly. Yeah, exit with code 1. So and it's going to print out the error. And the reason why I want to do that is because if I need to have the table inside of the database, I don't think I want to ignore that type of error. I want to stop log it fatal. And given that we have if not exists on true, it should ignore, it should not return an error basically. So for example, now if this wasn't set and the table was already created, it will return an error to say that the table already exists. But with this set, then that should not be the case. So we should not get any errors, and we're going to test that to see if it actually works and tweak it if we need to do so. So that is pretty much it on creating the scheme. All right, so we want to now ensure that we are able to create the schema, and that's by actually being connected to the database. And now I've noticed that there might be an issue here where this isn't accurate. This depiction isn't accurate. If we go back here, we'll notice that we're getting this that is saying that the connection is successful. But one thing that I forgot to do was to actually load in the .env file, so that this should not be the case. We should not be able to get this information in here. So usually what I like to do is to actually load the envs inside of the main package. So what I'll do is to go ahead and add the loading of the envs right inside of the main here, because this is where I prefer to add it, because I think it's probably the most appropriate place to load it. It's just one time, it will work across the whole entire project, so that's what I prefer to do. So we need to actually get this inside, so let's go ahead and do an import of what's it called again. So it's at github.com/joho/go.env, and I just saw it just now, go.env, and now we can go ahead and have that imported. Why isn't it showing me what I want to see? I guess probably I already have it installed, do I? See here. All right, let's try to use it then. So let's do a, well, we need to get, we're gonna get an error. So it's pretty much going to be go.env.load, and that's pretty much it for us to load it. but this returns an error if something went wrong. So we're going to go ahead and get that error in. And because it's the only thing that's being returned as an error, we can pretty much just do something like if, and then check for the error if it was nil. So we could do so. And this is just a one-liner syntax. I don't remember exactly what it's called. And then we can do a log.fatal because I want this to, I actually want to panic this thing out because I want this to crash if the envs are not being loaded. So this should be nil here. So we definitely, well, I think in the documentation they actually do log.fatal. So let's follow what the docs has. So log.fatal. So I want to always ensure that our env is loaded because are loaded because we need the envs to connect to the database because we need a database for the application. So we want to always ensure that this is the case, and that is why we're doing it like this. And because we have only one error being one variable or thing being returned, then we can do the shorthand syntax here, which is pretty cool. If we were getting something else, we don't necessarily want to do this because this is only inside of the scope. So if we're getting something like ORM or whatever, for example, for argument's sake, we wouldn't have access to this outside of this branch here. So we don't really want to do that in that sense. And now I think about it, I think this is what we should have done for this one as well. So let's go ahead and change the implementation of this, and we could just go ahead and cut this right here and just put it right here, and that looks a lot better in my opinion. So that's there. So let's save that, and that's formatted properly, and that's pretty much it. The next thing I want to do is to actually just change this to an else, to an well, else, and then we can put this right in here. So this is a condition. If this is nil, then the database fail, else the connection was successful. And that's the only time it should print this out and not just run and then print it out, because that's not correct. Because if it's not loading, then that's not correct. So that's pretty much it, and we could pretty much go ahead and try that out again to see if it's working as it should. So if I go over here and run this, you can see that we get successful connection. But let's say we didn't load the envs. Let's say we didn't do that. Then you can see that we get an error. So it's saying that a PostgreSQL connection. So we're not getting the appropriate error here. We're not really getting the appropriate error. So I'm gonna try something else to see if that would help. So we could do the opposite. Well, that's exactly what we're doing there, and it still didn't work. But it's saying that it's connected, so maybe it's connecting, but I don't know. Probably it's connecting. I honestly don't know at this point, but it should really, in my opinion, should be giving us an error if it, because the information is not there. So why are you saying that it's connected? But enough of that. We're gonna leave that for now. Maybe we can come back to that at a different point. That's pretty much it. The reason why we got that error here is because it didn't migrate to the database, or this didn't go over to the database because it wasn't loaded. But now, where are we? If we go back to main, and if we load this again, save that, we get all of what we need. It runs fine and we don't get any errors or anything. I had mentioned to you that this is what this temp is, if not exists, is doing. If I set this to false, then if we go ahead and go over here and run it, we'll get this error that is already created, which is super fantastic because that's what we want. So now if I should open another one of these and just do PGSQL, I go to our Postgres user, change over to Go. Then if we should describe this, now you can see that we have these in here that were not here before. So this automatically created the schemas for us. And again, we don't have the relationship just yet, but that's something that we can add later on if you guys would like. So let's go ahead now and move on to the next important things that we'll be needing here. We won't use this, so I'm just gonna comment this out for now. So the next important thing that we need is to actually start to create the different endpoints that we'll be using inside of a product. So let's go ahead and now do that. So we want to get the router in. So let's get that here. So github.com/gorilla/mux, and let's see. Okay, so we already have it installed. Let's go ahead now and create an instance of this. So it's going to be mux dot new router, and at this point we will go ahead and create our first handler. So we can say our dot handler func, and in here we can create our endpoint, and I'm just gonna go ahead and go with a conventional way of doing things, and that's adding like API as a prefix and then the version. So that's our version. We're gonna go ahead with version 2, or we could just leave off the version for simplicity, I guess, and then do products. But API version is something that I highly recommend, and I'm actually gonna put that there because the best practices, I guess, given that I'm using environment variables, I'm gonna go ahead and add version in as well. And the other best principle is that we use like the pluralized form of this instead of like the function name. For example, the handler that we're going to be creating is our create product handler. So we don't necessarily want to have this inside of our REST API endpoints. We want to have it in this format, and if we're going to be getting one of these, then let's say for example by ID, we'll just add the ID to the end of it, just append it to the end of it. So that's how I guess a recommended way of doing this. Next thing that I want to do now is just to add the method that we're going to be using, which is going to be our post method. And we haven't created this function as yet, and this is why it's screaming at us. So let's go ahead and do that at this point. So I'm gonna declare function, and this won't return anything, but it will take the response writer. So that's what we're going to be adding in there, and that's our function right down there. But even before we go ahead and do that, we want to ensure that our server has started, and that's the last thing that we want to do. So let me just add a comment here to say that we're starting the server. So starting server, and right here we're going to log that fatal, and this will take the HTTP listen and serve. So you can see at the top there it was imported right there, and this is going to be listen and serve, and this will take a string of the port and the handler, so the address port. So we're gonna get the default. Well, it takes the address. All we're gonna do is just append the port because we're using localhost here, and it takes the handler, the HTTP handler, which is going to be this here. So you can see router handler. So we're gonna put a port of 8000, and we're gonna pass R into that because this is our handler, and it should actually be handler func and not just handler. So that's our handler there. So that's the server starting right there. So now we can go ahead and actually create endpoints. And the first thing that I want to do here is just to go ahead and write the header, and we're going to set this to content type JSON, because that's what we're going to be working with. So content type, which is going to be application JSON and not just JSON. So application slash JSON. And at this point we want to be able to connect to the database, and since I have this right here, why not just be lazy and just copy it. So let's do that and paste it in here. We want to uncomment this now, format, and give it some space, and then we're closing the connection because that's important, and we're deferring it to be the last thing that actually happens in here. So moving forward now is that the next thing that we want to do is to create an instance of our product as we would have done at the top here. So we could pretty much just go ahead and copy this again, and that's how being lazy, you're always gonna be doing a lot of copying and well, it's more efficient, obviously, but we don't need the rest of these. So let's get rid of these. These are going to be coming from our response. And let me format this a bit. That didn't go as planned. So let's try to do this again. Bring that down. Bring that down. Now it looks a lot better. And this will take a comma there. We want to save this so that it imports the Google UID. So the next thing that we want to do is, which is extremely important, is that this uses a pointer type of thing. So we want to put this ampersand here, or else it will not be able to create it or add it to the database. It will give us an error each time. So it will run as if everything is fine, but it gives us an error, logs out an error to us to say that some pointer thing or whatever is missing. So we need to add this right here in order to be able to insert it into the database or write it to the database, basically. And the next thing that we want to do here is just to decode what we're getting. So let's go ahead and have that underscore set equal. So basically we don't want to receive but nothing. So new decoder, we're going to decode the body of the response that we're getting. Response. Let's see if that's, yeah. No, the request that we're getting, not response by mistake. And then do a decode on it. And in here, we're going to put the product on the inside. So again, let's see here. We're getting the return is a JSON decoder. This one is an error. I think is an error that we're returning, but we want to, well, for now we can just ignore it, I guess. Maybe later on if we need additional validations we'll add that, but I don't think we need to do that right now. All right, so the next thing that we want to do now is this is going to give us the ORM result. So we could set this equal to result. I'm actually gonna ignore this because I don't want it. It's usually either null or just some empty brackets, so I don't want that. It will also give us an error, so we definitely want that. So we're gonna do db.model and we're gonna pass the model in, so that's what we would have created up here, and then we're going to call the insert function, and that's pretty much all we need right there. But we want to also check if we have an error. So if we have an error, I'm going to we're not just gonna, well, I'm gonna log the error. So I'm gonna print this to the console. I think that's important, but we also want to send this back to the user or give them some information. So we're going to use a writer, and we're going to write to the header an HTTP response, which is going to be of status bad request, because usually, in my opinion, it will most likely be a bad request why you can't get it to the database. So again, I'm gonna ignore that. Maybe later on we could add get whatever. Well, as I mentioned before, it's just usually just returns an empty object or null. So I don't want that. So the next thing that we want to do, or pretty much the final thing that we want to do, is to create a new encoder, and we're gonna pass the writer to it, and we are going to encode our product. So this is what we're just sending back to the user, because I think this is probably more appropriate, so they see exactly what they created. So that's what we're going to be sending back, and this is pretty much all we need to create our product. So I'm gonna put some comments here. So this is going to be our create product. We're going to get connection here. We're getting a connection here. And the next thing here is that we are creating product instance. The next thing here is that we are decoding the data, or decoding request. And the next thing here is that we are inserting into the database. And the final thing is that we are we're basically writing to the returning the data, returning product, and this is the one that's inside of the database. So that's all really it takes to create the product, and this is extremely simple to do. So just we're putting it up as application JSON, but it should be inferred. We're getting the database connection, creating the instance of the product, adding the user ID as a new UUID, in decoding the data that is sent over to us, and then we're going to go ahead and insert it. We check for an error. If we have an error, we're going to log that error, and we're also going to return a bad request to the user, and then we're going to encode back the information if everything was successful and pass it back to them. So that's pretty much it. And now we can test out how this works, and I have this HTTP client here, and I'm going to create a new request, and this is going to be going to not HTTPS but HTTP, and this is going to be localhost, and the port was 8000, and this is going to be API/v1/products. And we can go ahead and create an instance of this. It will take this information here, so this is automatically created, so we only are going to be needing the name, the quantity, the price, and the store. And the store now is going to be, if we describe products, this is going to be JSON-B, which is pretty much just JSON, as I don't know, it's just pretty much just JSON. All right, so let's go ahead and create the name, and I have nothing original, so let's go ahead and do product, my product, and it takes a quantity, so that's what we're going to be adding here. It's an integer, so let's do 10 as we had before, and then it takes a price. This is a float 32, and we're gonna do the same thing. And for the product, the store now, it's just going to be a JSON object, and we can create this one for this instance. So we're gonna add an ID, and that's going to be a string. Actually, it's gonna be a UUID, and this is going to be a name, and this is actually going to be I don't know, we're gonna say Fedora store. It's going to be our Fedora store, and that's pretty much all that we need as it relates to the structure of this here. We're gonna create a UUID here. So for this instance, what I'll do is I'll stop this. Well, before we do this, what I can do is to go ahead and run, for example, this. Let's create a little generation function to generate UUID. So let's go ahead and say new fmt.print line, and we're gonna print a new UUID, so that we'll be able to add it to the store as we're doing it. So this will basically just generate a UUID for us that we can pass into here. And ideally what you want to be passing in here is actually just a store ID, and then the relationship will be created, so you'll basically have a reference to the product or whatever. So that's what you really want to do. But for simplicity, I just wanted to go ahead and do this. And as I mentioned before, if you want to see how we do the relationships, then just let me know. All right, so important thing that we want to do is actually have the server running. So let's go over here and go ahead and run that, so we get our UUID here. So I can copy it, and then I can go ahead and paste it right into here, and then we can go ahead and change this over to post, because it's a post request that we're sending over or we're using. And then we can do send, and now you can see that it sends back the ID, and it sends back the product name, the quantity, all of the information that we would have added there. And now you'll notice that we didn't have an ID when we actually sent this over, so you can see that that's definitely working. If we go over to the database, you can see before we even go there, we can see that the connection was successful. If we go to the database and do a select all from products, you can see that we now have a product inside of our database, and I am seeing something weird, so I'm trying to figure out what that is. Let's run that again, and this is the ID that we're getting, which doesn't look like a UUID, so that means something isn't working as is. but I don't think that is all that important, or that's something that we can fix later on. I don't know why that is though. Let me small this down a bit, and I think I noticed what the issue might be. So if we scroll back up, you'll realize that this says byte A, and that's why we're getting this and not exactly the UUID, and not exactly the UUID. So, and I don't like that. I don't know why that's showing that as is. It should have actually just set it to a UUID, but I don't know why that is the case. So what I'm gonna do is to actually just change this out to a string and save that as is. I want it to be a string because I want to see the actual representation of it. And then what we can do now is to just set this as a string here. So add the string function to it. So that should be that. And now I'm not sure if it will like do the updates for us. To be honest, I may have to drop the table. So we could try still and see what happens. So let's go ahead and stop that, run it again, and let's go over here and see if it will change the structure of it. Let's describe products, and it does not. So what I'm gonna do is to actually just go back to our Postgres user, and I'm gonna go ahead and drop the database, go and then create it back, because I actually just really want to see exactly what we're adding in there, but I think it should have picked it up though. I don't know why it's not. Let's go to go product REST API, and now we have no relations. But if I go ahead now and run it again, so let's stop this, run again, and now if we go over here, why did that happen? It didn't do the thing. It should have ran this, but it did not. Or did it? All right, let's try that again. Or let's look at the main again and see what's happening. Oh, so we didn't do a connection to the database. So it would have happened when we did the connection. So let's try that again. So go ahead, run, because we want to actually have that connected. So now it's connected, and now it should have sent over the information. So you can see now we have our tables, but we want to not have this run because it's not being used. So let's get rid of that. That's that. And now if we describe the products, then you can see that it's now text or string or whatever. And that's because I just really want to see the UUID. So if we go over here now and send the request again, get a new UUID. But now if we look at the database, look at all the products, you'll notice that we now have the UUID, and that looks a lot better to me. So I want to keep it that way. So that's that, and that's pretty much how we go ahead and create a product. So the next thing that we want to do now is obviously to get a product from the database. So or get all of the products actually before we even get a single one. Let's try to get all of them. So what I just did was just duplicate this or copy and paste it down. And this is going to be our products get products endpoint. And this is going to be a get request. So get all caps. And now we need to create this method here. So let's say get products and declare our func and paste that in. This doesn't return anything. Again, it takes the writer and the request. Here we're gonna do a lot of things very similarly. So I'm gonna copy down most of these, including this here. So let's go ahead now and paste all of that in, and then we're going to continue from here. So what we're doing is that we are setting the header, getting the instance of the database, and then we're going to be creating products splice, and here we are going to just do var products, and this is going to be a slice of products, or product basically, and then we want to get all the products from the database essentially. So at this point it's just getting it. So I select passing the products variable as, I think that should be pointer, and our reference or whatever. I don't exactly remember at this point, which is really sad. But this returns an error, so we want to check for that. And we're going to use a shorthand syntax again. So check if we have an error in here. And if the error is not equal to nil, then what we're going to be doing is to, I'm going to panic this out, because for some reason I don't know why it wouldn't. Well, actually, since we're using the login of it, let's go ahead and just continue on that end. Let's do that. And this again only returns the error, so we can do that. The next thing that we want to do at this point is just to write it back to the user. So we're gonna do encode, and then we're gonna pass products in here, and that is pretty much all that we need. So I'm gonna copy this here, paste it in, and then we're saying we're returning all the products. So it's pretty much as simple as that. Writing the response header, setting the content type in the header. We're getting the DB instance or connection, and then we're closing it, which is important. That's the last thing, so we had differ as well. Then we create a variable of splice, product splice, and then we're selecting all, and we're getting an error return. So we're checking if that's not nil. If it's nil, if that's the case, then, or if that's not the case, then we're pretty much going to be logging the error, and then we're returning that it was a bad response to the user, and then we're sending back all of the product information. That's pretty much all that does. So at this point we only have one product in the database. So if I should do something like what does this do? I don't know how to clear this out. So I wanted to like not have anything. So pretty much what I'm doing here is just not having anything in there, so that you guys see that it's returning the correct thing. Before we even continue, we need to ensure that we restart the server. And at this point, we can, what's happening? We can change this to a get request, and this will do a get, and you can see that we only get one product. But we only have one product, so that's not 100% proof of concept. So just go ahead and do that. So this is, we're gonna go ahead and do this is my newest product. I'm gonna introduce a new error into this. So what we want to do here is to copy this, and I'm gonna put a different store ID on this, but it's actually the same store. So we obviously have an error here. This is going to come in handy when we're doing the update of the product. So that's why I'm doing that right now. So, and actually let's change the name as well to just Fedora, and let's send this across. So we're posting a new product, and you can see that it sends it across with a different ID, but we don't necessarily want that. So if we go ahead and do a get request again, now we should be getting two products. So we get our my product, and we're also getting our my newest product, and both of these are or should be inside the database. Well, obviously they are in the database. That's why we're getting them back. So you can see that we have two of these, and I can expand this a bit so that it looks better. So you can see that we have all of the information that we need on our product. A little bit bigger wouldn't be too bad. All right, much better. So there we go, all of them in one line. So that's pretty much it as it relates to now getting all of the products from our products endpoint. So the next thing that we want to do now is to actually just get one single product. So this is where our variable is going to be coming in handy, as I had mentioned before. So we could just pretty much do something like this, and this is going to be get product, and it's going to be a get request just the same. So if we go ahead and copy that down and create a func for this, paste in the name, this takes a response writer, it doesn't return anything, uh, and then we can just copy some of the information that we have here, and let's just go ahead and copy this down to this part because we need this. Let's paste that in there, and the next thing that we want to do here is to actually get the param. So we want to get param or get ID. So this is the ID that's coming in from the URL, and at this point we can just set a variable that's called params, and this is going to be mux.vars, that's what I call it, and we're going to pass in the request that is being sent across, and then we can just create a variable called product ID, which is going to be set equal to params, and then this will take the product ID in this syntax there. And right here we want to create an instance of the product, and this is where we're going to be passing in, because the whole PG Go package has this really good where PK function that will just accept the primary key, and then that's what we're going to be using. So that's why I want to just add the product. Well, we're going to create the instance of the product here, and again we have to have this thing there. So product that we're creating, and then we're just passing the product ID. Differently, what you could do is just do a where, but this just makes it much easier for us when we have it like this. So that's why I'm using this syntax here. So we want to go ahead and do the db.model, and we want to pass in the product inside of here, and then we can use a function either where, but for this instance I'm going to go ahead and do a where primary key, because if we did here you're gonna have to pass in a condition in there, and you can add optional parameters, but for the where PK it will, so you can see where PK adds condition based on the model primary key, and we already had it in there, but it seems like it's pretty much just a wrapper around the where just the same. But this is just much simpler, so why not use it? The last thing that you want to do is to ensure that you add the select, because we want to return back everything. So this is important that you ensure that you add the select here, and that's pretty much it. This is that, and this returns an error, so we want to ensure that we actually capture this error like so, and we also want to validate or verify this or check if we have an error and do something. So if there's an error and the error is not equal to nil, then we want to return that, and we're pretty much doing the same thing as we would have done in previous times. So just copy this here to say that it was a bad request, and we're not doing a lot of validations in here. There's a whole lot of other stuff that we could do, but for simplicity, just why not just do that, just keep it simple. So at this point we are returning the product, so let me copy this one because it's just a single product that we're returning, because we're getting one product, and let's just paste that right there, and that is pretty much it as it relates to getting a single product. You can see how simple these really are. So that's that. If we now go ahead and let's say for example we copy the URL, well, before we even go any further we need to restart the server in it. So let's go ahead and restart the server, and right about here, where were we here, we can copy this here, and then we can just put it after this just like so, and it's the same get request, but at this point you will only get one of these. So if I do send, you can see that we only get this right here because that's the product, and if we made an error in this, you can see that we get that it was a bad request, but we returned the information. So what we want to do here is actually an important thing that should happen is that on each of these we should do a return because something went wrong, so we don't want to continue the program any further. So what I'm doing is just going to go ahead and add a return here, so it doesn't return any information back, only the status code that it was a bad request. So that's really important. So let me stop the server here, run it again, and if I go ahead now and send over the request, it sends back nothing, which probably we could create like an error and say, well, this is that or this is that. But a bad request is totally fine for this simple example. But if we now go ahead and set it back to what was right, so I just did a Control Z, and now we're getting back the correct information. And if we remove all of that, including the slash, and do a get, we get back everything, and we can try this on this, for example, this other product. So I did a Control C to copy and Control V to paste, and now we're getting my newest product, but this one has the error in it. So that's the next thing that we're going to be doing by basically going ahead to do the update of our product. And I think that one is going to be a little bit longer, so I'm gonna basically just go ahead and do the delete first before we even go into the update, because that one is a little bit more, not necessarily complex, but takes a little bit longer. So let's continue on the simple path, and what I want to do is create this first. So for the delete, it uses the same syntax. So same thing, we are getting an ID that we want to actually delete, and we're just gonna change this to delete, and this is going to be a delete request. So did I copy this? There we go, copied. And we can go ahead and do a, let me just put a, well, I need to add comments to this. So this is going to be our get product, and right here this is going to be update. This is update product, and I want to put and a little asterisk to say store as well. Store, because we can technically update the store inside of the product, which should not be the case, but that's something that we can do as well. And we're gonna leave that as is, and right here we can do our delete product method. So let's do a delete product, and right here we're gonna create the func declaration create delete product, doesn't return anything, has the writer, response right on the request. And again, we're going to just get some of the information that we will be using in here. So pretty much all of this information we want up to about here. So, and I just realized that I didn't put the product instance on it, because it's actually an instance. Is it? Where did I put it first? Yeah, so creating product instance. So it's right here. We're technically doing the same thing. We're creating a product instance. So I'm gonna put this right here as well, because that's true for it. Same thing for here. All right, there we go. So the next, what we want to do now is to actually, we could do it by primary key as well. We could do it a where, or we could do it by primary key. And I think primary key is actually quite the thing. So in this instance, remember earlier we didn't really use the RM, but for this one I think I'll actually want to use the result, or not the RM, the result. So we could say a result is going to be and the error. So when I set that equal to the db.model, because we're going to be checking these, we're going to pass a product, and right here we could do something like a where. We could do where pk, could do where, and we could do where pk, which is something that you would have seen before. But for this instance, what I'm going to do is I'm going to do where primary key is actually equal to the ID. So we could say ID is equal to that, which is basically our prepared statement to have a syntax, and then we could add the product ID in here, and then we could just call the delete function, and that's pretty much it. So right here now we could, I'm gonna be lazy again, and we're gonna copy, where is one that, here we go. So we're gonna copy this one. You see it's a bad request, and you guys may have noticed I've done something that's sort of redundant, or probably use, well, not necessarily use, well, so let's paste it right there, and now, and this is actually not needed, to be honest. Right here, the information that is in here, because we're really passing in this already into this. But the reason why I do this is because I'm gonna copy this down, and I'm gonna put pk here, and we can remove this. This is a function. We can remove, what am I doing? So this here, this will work with this right here, or we could pretty much just use this right here. So it's just an alternative way to do this. So let me just paste that in here to say that it's an alternative way. Let's remove that. This one would not need anything inside, while this would work with this. So creating product instance, and same thing here, alternate. I'm just gonna say alternate way, and I'm gonna comment these out. So that's that. The final thing that we want to do now is just to return, the result of the deletion. So that's what we're going to be passing in here. Could, no, I don't think I want to return could return a product, is it? It should be an empty object though. So it should pretty much be the same thing. It would be an empty object, just as the result would be an empty object, because it's not returning anything because it's gone. So that's it. But that's pretty much it as it relates to deleting a product. Again, it's the same syntax. We write the header, or we set the header basically, get the instance, get the param, which is the ID, and then we create an instance of the product. And I think this should be the alternate way. I don't know. This looks more like it as what we were following before. This looks alternate way, and then this is right there. That makes more sense to me. So create a product instance, and then we delete using the where condition of using the ID. If we have an error, then we're going to log the error, and then we are going to write that it was a bad request, and then we're going to return and not go any further. If it was successful, then we're going to return the result to the user, which is usually just an empty thing, or null maybe. All right, so that's pretty much it as it relates to that. So if I go ahead now and stop the server and run it again, if we go over here, then this request was a bad one. So let's go ahead and actually just delete this. And fortunately, it's already there, so we can copy, not request. This product was a bad one because we have the wrong ID. So we could pretty much just go ahead and paste that in here and just change it to a delete. And then we can send this over, and you can see that we get a 200 response, which means it was okay. And then we get an empty result there. So if we go ahead and do a select all from here, then we should only get one product. And also within the database, if we do a select again, you can see that we only get one product, and this is our original one, our Fedora store. But I actually want to send this back because we want to have it to do the updates. Well, so we want to send it to first to be able to do the updates on it, so that it's the same. We select again, you can see that we now have back the product in there. It was gone, now we have it back. So the reason why I send it back, as I mentioned before, is just so that we can do the update on it. So the next thing that we're going to be touching on at this point is just how we can go ahead and actually update the product. So let's do that now. So this the same thing. We need the ID. It is going to be an update, and because I want the sequence to be the same, that's why I'm putting it above the delete. So I want the sequence to be the same, and this is going to be a patch request. Could be a put, but well, usually I think what they say that when it's a put request is you're actually changing everything, including like for example the ID as well. So I think that's why I'm using the patch, because it means that you only change like parts of it, if I remember correctly. So right here we're going to add that in. So func update product, and this doesn't return anything, but we take the writer and the request, and again we're doing pretty much the same thing as before, copying to be lazy and all, and this takes everything down to this point right there. Paste that in. So we need a product instance along with the ID, which we could use a where, but we're gonna use where primary key just to be lazy, or where pk again. At this point we want to ignore the result of the encoder or the whatever is returned. So new, well, not encoder, decoder actually. I'm gonna pass the body in here. Should be a common R or lowercase r dot decode, and in here we're going to add the product in here, and that's that. So at this point, again, you know the drill. So it's db.model, passing the model, and at this point we want to use the where pk because we're adding it from here already. So why not, instead of doing the where clause. So we're going to go ahead and do a set, and we're setting the different values that we're going to be updating. So the first one is going to be the name. For example, if we're updating the name, so name is equal to that, and this is pretty much just the purpose statement type of syntax where you don't necessarily add it inline, because this is a security risk if you do that. So we want to go ahead and do quantity as well, because that's another thing that we're adding. And if we're updating the ID, then we could add that as well. We want it updated, but we won't be doing that. The next thing is going to be our price, and the final thing is going to be our store, which we're going to add in. You're gonna see how we're going to add that in here. So you can pretty much just go ahead now and just add in the values that we'll be needing. So we want to have the product dot name, which is going to be in the request, and we want the product dot quantity. It's also going to be in the request. I want the product dot price. So product dot price, which is also going to be in the request. The store, on the other hand, we're going to create an object for it. So we could pretty much just say product dot store, and this would work. Actually, this should work, because what we could do, is we could create like a store struct, or well, a map actually. So we could put a map interface, for example, of string. But I want to believe that given that we're sending it back as JSON already, we should be able to say product.store. But if it's a case where we actually need to for example, edit it in some sort of way that we do some sort of changing or whatever, then I think this should be fine. For example, we don't necessarily want the person to be able to update the ID of the store. Then at this point we could get the store ID and then just pass it back here. This is just an alternate way to do this. So we could say alternate way to update store. And I want to also add this, how we would add the store in here as well. Let's go to the end of this and we'll just pass store in here, and that's pretty much how it would do. And again, this is just another alternate way to update the store again. Let's copy this to include store. to include store in update. And that's just that. One thing I want to add is the update function here. That's the final thing. So we can call the update now. So that's our update function. That's pretty much it for that. Again, this actually returns an error. So want to, well, it actually returns two things, doesn't it? See what it returns. It returns the RM result and also returns the error. So we're gonna ignore the RM result for this one, but we want the error, obviously. And it's going to be the same thing as before. So we're gonna check for that. Well, we have an error. We're gonna log it. We're gonna log that error, and then we're gonna print out the information. Well, we're gonna return back to the user that they would have had an issue, or there was an issue, pretty much. That's that. And then the final thing that I want to do at this point is to just go ahead and return, well, it's just one product we're returning, and that's the updated product. So if we go ahead now and bring this down, I'm gonna paste this in here, and that's pretty much it. So this is the same instance of this product I would have created up there. That's what we're pretty much just returning right there. And yeah, that's it for updating of the product. So our store included, and again, we probably just, if you guys request it, then we can create a actual video on how we can do the relationships to actually have to update from a different place with the store, so you wouldn't be able to update the store from the products. So here we set the header, or the content type actually, then we get the instance of the database, get the ID, create the instance of the product, decode the product or the request that we're getting into the product here, and then we have this alternate way of creating a product instance, so we can pass that into our store update there, so you can see how we pass that in. Else, this is the other alternate way that we can do this, and that's just to pretty much, let me just bring this on a bit. So this is pretty much just to I'm gonna put this up here. I'm gonna put this up there as just one thing. That's just one thing up there. So else we can pretty much just go ahead, primary key, and set these values in here that we want to update, the ones that we actually want to update, and then we just pass back whatever is being sent across, and then we call the update function. If there was an error, then we're going to print the error out or log it out, and then we're going to write that it was a bad request and then return from the running of the program there. And then we're going to, if it was successful, we just go ahead and just return back the product that was updated. So that's pretty much it. So we need to restart the server, and you can look up the information is here. I'm going to change it so that it's almost identical. So let's go ahead and stop the server here, rerun it, and over here, this is our product, but we want to change some stuff from it. But before we do that, I want to go ahead and send over and get all the products that we have. So this is the correct store ID. So let me go ahead and copy this. Control C and then Control V, paste over. I didn't do that correctly. Let's do that again. Paste. So we have the correct one now, and this should be Fedora Store. This is going to be a more expensive product, so let's say $100. And this is going to be $9.99. I don't know what's that expensive. Well, let's put 5 as a quantity. So it's rare but just more expensive. So newest product, and if we go ahead now and post this, well, it's a patch request. So if we go ahead and send this over, method not allowed. I just realized the error, my bad. So if we go ahead and send back the get request on here, this is what we want to do. We want to update a specific product. So let's go ahead and pass that in. And now we can go patch request, send it over. So now you can see that it's now updated. And if we do a request on all of these, then you can see, well, I'm just getting back the single one, not all of them. So if we go ahead now and send it over, you can see that we have some updates. It's now 5, and the name
of the store, and the ID would have been changed. So that's pretty much how we can update a product. And again, it can be in a more sophisticated way, but we're just keeping it simple for this tutorial. And that's pretty much it as it relates to this. So we are now able to create a product, we are able to get the products, we're able to get a single product, and we're able to update the product and the store, I guess. And we're also able to delete a product from this. And if we go over to the database as well, you can also see that the changes would have been reflected inside of here. So we have the identical store because that's what we want, but the quantity, the price, the name, and the IDs are totally different. That's pretty much it as it relates to that. And yeah, so thanks for being on this journey with me, basically recreating this project here. And I'm very thankful for Brad for creating this and allowing us to really follow along and being able to improve. Again, please check out the channel if you haven't as yet. That's pretty much it. I'll have this code uploaded to GitHub, most likely under the Federal Education um, organization, and I'll have it over at the EDU Fedora website, and I'll leave a link to that. So thanks for watching, and I'll see you guys in the next one.